Hi Math 2. This is a lesson on Unit 7, Lesson 8, and we'll also be discussing Unit 7, Lesson 9. And this begins in your book on page 204. So we're going to be learning how to find the area of sectors and the lengths of arcs. And we're going to be learning a formula to use for that. But let's see where our math comes from. Let's begin by looking at the first shaded picture right here. If I wanted to find the area of the shaded region, I would note that it looks to be half of a circle whose radius is 8. So as a reminder, the area of a circle is pi r squared. So the area of that entire circle would be pi times 8 squared. So it would be 64 pi. That, however, is not the area of my shaded region. My shaded region is only a portion of my circle. It happens to be half of it. So I would divide this by 2 because it's half of my circle. And the area of my blue shaded region would be 32 pi. In math, we call this shaded blue region a sector. It's a portion of the circle. And we call part of the outside of the circle, we call that an arc. So let's take a look at page 205 in your workbooks. On this page, we're going to be calculating both the area of the blue sectors. We're also going to be calculating the arc length. So we're going to find the blue shaded area, and we're also going to find the length of the arc that runs around that shaded area, a portion of the outside of my circle. So we're going to use two formulas for this. The first formula we're going to use is the formula for the area of a sector. So the area of a sector is equal to the part of the circle that is your shaded area. So that's theta divided by the entire circle, 360. That'll tell me the portion of my circle. Is it half the circle? Is it 3/4 the circle? Is it 1/8 of my circle? What part of my circle is shaded in? I'm then going to take the portions that's shaded times the area of my whole circle. So once I know the area of my circle and I know what portion is shaded, when I multiply those numbers, I will find the blue shaded region. So I'm going to use something similar to find my arc length. So arc length is done the same way. I need to know what portion of the outside of my circle I'm trying to find. Am I trying to find the length of half my circle, a fourth of my circle? Is the arc 2/3 the length of my distance around my circle? So I have to find the portion of the circle that is my arc. So that's theta divided by 360 times then the distance around my circle. If you'll remember, that circumference. That's 2 times pi times the radius. This formula will tell me the length of my arc. So let's take a look at these 3 examples. So in the first example, we're going to find the area of my sector. So to find the area, we abbreviate that with a capital A. So in this problem, my area is equal to theta divided by 360 times pi times the radius squared. So theta is 270 degrees. From the beginning radius to the ending radius is 270 total degrees. So my area is equal to 270 divided by 360 times pi times my radius is 10 squared. At this point, it's all algebra. It really depends on how you want to put it into your calculator. But this is 270 divided by 360 times 100. And when you do that, you get 75 times pi centimeters squared. And that's a great answer. And the book, you'll notice, it says give your answers in terms of pi. Sometimes we give decimal answers. Those are approximate answers. So I would go ahead and multiply 70 times my pi. And when I do that, I get that the area is 235.6 centimeters squared. Both those answers are good answers, and sometimes we want the exact answer. The exact answer is in terms of pi, so this would be considered an exact answer, and this answer would be an approximate answer. And there's a use for both those in our math work. So now let's discuss how to calculate the length of an arc. So to find my arc length, we abbreviate that with an S. So S equals, here's my arc length formula. S equals the portion of my circle, so theta over 360 times 2 pi r, which is the circumference of my entire circle. So for this particular circle, I'm talking about the arc that runs 270 degrees around my circle. So that's the portion of the circle. It looks to be 3/4. 270 divided by 360 would be 3/4. So 270 divided by 360 times 2 times pi times my radius, which is 10. Again, this is all math at this point. It's 270 times 2 times 10 divided by 360. And when I put those numbers into my calculator, I get 15. So 15 pi centimeters is my arc length. Again, this is an exact answer in terms of pi. And sometimes we want our answers in terms of pi. Other times we want the decimal answer. So let's go ahead and find that. 15 times pi would be approximately 47.1 centimeters. So let's take a look at the next two problems. Again, to calculate my area, I need the area formula, which would be theta over 360 times the area of my circle, pi r squared. So I get 60 divided by 360, which reduces to 1/6. So this blue area is 1/6 of my entire circle. So I'm trying to find the area basically of 1/6 of my circle times the area of the whole circle, pi times 12 squared. So mathematically, this becomes 60 times 12 squared, which is 144, divided by 360. And then when I throw those numbers in my calculator, I get 24. So this is 24 pi centimeters squared. And you can multiply 24 times pi on your calculator to get the decimal answer if you would like that. So let's take a look at the sector, the arc length. So the length of this arc, we already know that it's basically 1/6 of my circle. So I'm going to use the total distance around the circumference, and I'm going to be dividing that by 6, multiplying by 1/6, same thing, to find out what that blue arc length is. So let's start that. So my arc length, which is abbreviated with an S. So I'm not sure why that is, but our textbooks, videos, they abbreviate arc length with an S. So here we go. So I have theta over 360 times the circumference, which is 2 pi r. So my portion of my circle is my 60 degrees divided by 360 times my circle's circumference, 2 pi times 12. So this becomes 60 times 2 times 12 divided by 360. And when I put that into my calculator, I get 4 pi centimeters for the length of my arc. And I could multiply 4 times pi on my calculator to get it in decimal. And let's do the last one. At this point, if you want to pause the video and try it on your own and see if you and I get the same answer. So here we go. Area equals my theta, which is 135 divided by 360 times my pi times my radius squared. Again, I put 135 times 16 squared divided by 360 into my calculator, and I get 96 pi centimeters squared. And then for my arc length, the same 135 degrees divided by 360 is going to tell me the portion of my arc that makes up my circle, times 2 times pi times my radius of 16. And when I put 135 times 2 times 16 divided by 360 into my calculator, I get a 12. So 12 pi centimeters is the length of that arc. So this arc is 12 pi centimeters in length. So at this point, hopefully you got that one. If you take a look at the notes, so please turn to page 207. You'll notice on page 207, number 2, it says that this image shows a circle with a radius of 5 and a central angle measurement of 160. Find the area of the shaded sector and the length of the arc. It doesn't say to find it in terms of pi, so you could find it in terms of pi, or you could give me the decimal answer. So at this point, I'd like you to pause the video and try it on your own, and then come back and check your answers. So let's take a look at this first one. You should have had that the area of your sector is theta over 360 times pi r squared. So the area is equal to 160 divided by 360 times pi times 5 squared. And I'm going to put all of that into my calculator, 160 times pi times 25 divided by 360, and I get 34.9 inches squared for the area of my blue sector. So now let's work on my arc length. So the length of my arc is equal to my theta divided by 360 times 2 pi r, my circumference. In this problem, that would be 160 divided by 360 times 2 times pi times 5. So I'm going to put 160 times 2 times pi times 5 divided by 360 into my calculator, and I get 13.96 inches for the length of my arc that extends along my blue sector here. So this concludes my notes on Unit 7, Lesson 8. There is a summary page with an additional example you could look at. So at this time, would you please turn to page 213 in your workbook. This would be notes for Unit 7, Lesson 9. It's really the same lesson. The difference here is our unknown is not going to be the sector area or the arc length. Our unknown is going to be our theta or our radius. So we're going to have to use algebra to solve for our missing variable. So let's take a look at 9.2. Let's call this example 1. So for this example, it tells me that the sector's area is 32 pi. So I know the area of this blue sector is 32 pi units squared. In this case, it's inches squared. And I know that the radius, actually I don't know the radius, sorry. I know that the central angle is 45 degrees. What I don't know is the radius for this problem. So let's find the radius. We are going to set up the same problem we did in Lesson 8. We're going to set up our area of a sector formula. The area of a sector was theta divided by 360 times the area of my entire circle, pi r squared. So let's put in what we know. We know our area is 32 pi. We know our central angle, our theta, is 45 degrees. And we don't know our radius. So At this point, this is algebra. It depends on how you want to solve it. So for me, when I look at something like this, I notice both sides have a pi. I'm going to divide both sides by pi, and that cancels my pi. And then I know if I would like to solve for r and it's being multiplied by a fraction, I could multiply the fraction by its reciprocal. In other words, I could multiply by 360 over 45, and I would cancel out that fraction. So I'm going to multiply both sides by 360 over 45. And on my right side, I'm going to have an r squared left. And on my left side, I have 360 times 32 divided by 45, because remember this is 32 over 1. So when I put 360 times 32 into my calculator, divide by 45, I get 256. And I'm going to continue solving for r by taking the square root of both sides. And I find that my radius was 16 inches. And that was the length of my radius. So let's take a look at another example that has missing information. We'll call this example 2. Can you please draw a circle? And in this circle, we're not going to know our central angle. We're not going to know theta. However, we're going to know that our arc length, so make your arc really bold. We're going to know that our arc length, our S, if you will, our arc length is 8 pi. And our radius is 10. So in this problem, my unknown is the portion of a circle. I don't know what portion of a circle. I don't know what theta is. So let's use our formula from lesson 8 for arc length. That was the portion of my circle times the circumference of my circle, 2 pi r. That's the distance all the way around my circle. So this particular arc's length is 8 pi. So from one dot to the other dot, this arc length is equal to 8 pi. I don't know the central angle, so I'm going to leave theta, and I know my radius is 10. So again, this now becomes algebra. So depending on how you want to do it, I do note I have pi on both sides. I'm going to go ahead and cancel pi. This is 8 equals 2 times 10 is 20. So it's really 20 times theta divided by 360. So I'm going to think of this as 20 divided by 360 times theta. I did a little rearranging. And so for me, I know I can now multiply both sides by the reciprocal. So I'm going to multiply by 360 over 20 to get all of this to cancel. So over here, I've got to multiply by 360 over 20. And on my right side, I just have theta left. And on my left side, when I do 360 times 8 and I divide by 20, I get 144 degrees. That would end the lesson for Unit 7, Lesson 8 and 9, Arc, Length, and Sector Area. So at this time, you have a worksheet of homework problems, practice problems, to practice using this formula. The first 4 are from Lesson 8. You're just going to use your 2 formulas. And numbers 5, 6, 9 and 10, let's call that 7 and 8, ladies and gentlemen. You're going to be solving for something that's missing. That was what we talked about in lesson 9. If you are unable to print this worksheet, just write your answers on another sheet of paper and go ahead and upload those to Google Classroom. Thank you.